Right, we've looked at the binomial probability distribution, which we can use for what we call discrete data, where all the data take exact values. So, for example, the number of people or shoe sizes and other things, dice throws and coin tosses and so on. So now we'll look at a different model that we can use for continuous data. And continuous data is data that we can measure. Typical examples for humans would be height and weight. And certain types of data, if you have a large data set, follow what we call a normal distribution. And in a normal distribution, most of the data will be centered symmetrically around the mean. Now, the way we could represent that in a chart would be that we represent the data as a histogram. So rather than having individual data points, we have these classes or groups of data that simply shows the number of individual data points within that group. So for example, if you look at the table here where it says height class, we can divide our data points, or we can divide the data set into groups. So for example, okay, how many people in this set weigh between 30 and 40? And then we could just, count them up. Do the same for 40 and 50, same for 50 and 60, same for 60 and 70. So the bars here, they simply represent how many individual data points is it within a specific class or group. And so these bars that you can see in the chart, they represent the groups like this, for example. And the smaller you make the groups, the thinner these bars are going to be. And you can make them very, very thin and have very small groups. And because this is different from discrete data, this is measured data, so you can make the groups as small as you want. And if you draw a curve through the top of the bars here, in a normal distribution, you would typically get this bell-shaped curve, which will be symmetrical around the mean. And the mean value will be the top of the curve. So the main difference then between the normal distribution and the binomial probability distribution is that we use binomial for discrete data, and we use a normal distribution for continuous data. Continuous data is data that we can measure. Another difference is that the normal distribution is often observed in nature. So we find this very often in the natural world, and it's therefore good for making predictions. So you could take a smaller sample and you could say something more general about the population as a whole. We could set up very simply how the differences are when it comes to how we model these distributions. So a binomial distribution, remember we have our random variable, we can call it whatever we want, but it's distributed binomially with the parameters n and p, where n is the number of trials and P is the probability for each trial. The normal distribution is different in this respect because, okay, we have a random variable, for example, height, and it has a normal distribution, and it has different parameters. So the parameters here are the mean and the variance. And I could add what I just said about discrete and continuous data. So discrete data and the normal distribution is used for continuous data. When we graphed the binomial distribution, we had these bars that represented the different values, the discrete values. So we have that total area of all bars equals 1, because this is a distribution of total probability. So if you add together all these probabilities, you will get 100% or 1. For the normal distribution, this is slightly different. So it's the total area, under the curve, because we can draw the normal distribution as a curve. We can make the classes, the groups, as small as we want, and this is going to be a continuous curve. So what we're doing here is really finding the integral value. We're finding the area under a curve rather than adding together rectangles. In the next video, I'll say a little bit more about the bell shape and what we can read out of it without using too much technology.